Hey everyone! This video will be the first video in a multi-part series that just goes over the different parts of your final project, the Parametric Pavilion, and just has some tips and tricks on how to approach the project, from massing to facade to structure and the like. So today we're just going to focus on the massing, and ultimately, because it's a pavilion, it doesn't have to be an enclosed space at an enclosed building. We're going to focus more on singular surfaces, as you can see here. And the reason for that is that's when you import this into Grasshopper and start to divide your surfaces and create the parametric panelization, it's better to have a singular surface. That's what it's going to read, and that's how it's going to break down everything. So that's how I've approached these examples. And today I'm just going to go through how different strategies of how to manipulate surfaces, create surfaces in Rhino to then be able to bring back into Grasshopper and Rhino.Inside. So I have opened Rhino up in Rhino.Inside in Revit. Obviously, you don't have to do that. You can open it in a standalone Rhino file, do all your modeling, and then save it, and then open that Rhino file within Rhino.Inside once you're done. But I've just chosen to do it this way, just so I can go straight into Grasshopper without having to close and open. So I'm going to basically hide these surfaces. I'm going to show you, I've already created the curvature, and I'm not going to spend time recreating all that because it'll just be a lot of time of you watching me draw lines. But I will go through how to create all of those different surfaces with this line work. So the first thing I did was I created the mass of the dimensional requirements within the project. So this is a 30-foot tall box, a 45-foot wide mass that is 185 feet long. And so what I'm going to do with that, I have it on a locked layer, and all I'm going to do is use it as a reference to make sure that the pavilion, the surface, the geometry that I'm making will meet those dimensional constraints that I've laid out. All right. And then so for this first example, all I did was I just drew a curve, and I actually originally drew it on the side of the box, and then I took that curve and I mirrored it, and then I just manipulated the points a little bit and drew some connecting curvature from each point. Right? Now, for most of these, except for this one right here, these are the self-supporting integrated structure. So they need to have at least 2 or 3 points of contact on the ground. You can have 2, but you're going to have to really show me how it's structurally supporting itself. So currently this one has 3 points. It has this leg, and this leg touching the ground, and then this guy lifts up. So the way that I'm going to do this is I'm going to use the command sweep 2. Sweep 2 asks for 2 rails and then cross sections. So this is really good. It's a little bit more definitive than and exact and purposeful than the loft. The loft just kind of takes 2 or more curves and lofts and creates a surface in between them as efficiently as possible, where the sweep 2 allows you to really define those edges of the surface that's not defined by those curves. So I typed in sweep 2, excuse me. It's going to ask for 1, so I'm going to select 1. Then it's going to immediately ask for the second. Select the second. And then it asks for sweep shades. Those used to be called cross sections. That must be new. So I'm just going to click the 2 curves, hit enter. And now I have this really interesting, unique, twisting curve, double curved surface this one I'm actually going to take and develop because I really like it. So that is the first one. Now, as you can see, double check with the dimensional requirements. It meets all of those. So all done. Hide those. This next one, here, and I'm going to hide these so that we can focus. So this next one focuses on creating a double curved surface out of straight curvature or straight lines. So all I've done is take perfectly straight lines. I've angled one, and then actually I've gone down and I've just rotated it, and I've created a higher density on one end and then a low density on the other. And then all you do, if you add this mass, you loft. And then when you're doing this, I have found that when lofting, you want to select the curves at relatively the same part of the curve as you go down the line. So I'm doing it in order, and I'm also selecting at the lower half, or what the lower half compared to our view, relative to our view, as I go down. And that will create this wavy, almost ribbon-like surface. Now this one would be more of a roof structure that you'd have to self-support with columns. But if that's what you want to choose to do, then by all means, go ahead. I'll show you what I mean if you select the wrong side or select the wrong order. So I've just selected that, and you can see I selected this half and then this half, and then the rest I selected on the lower half, and that's essentially choosing the direction of the loft. Now, if that's something that you want to explore, then by all means, go ahead and do it. But just want to make sure when you guys are creating this geometry, you're not running into that and not understanding why. It's something that's a little funky with Rhino, but I'm sure there is a computational reason for it. So I'm just going to loft this one more time. All right. So now that I have that one, I'll move it to the side. And move on to the next one. So the next one is focusing on a multi-surface. It's focusing on a multi-surface pavilion and a symmetrical, or a symmetrical pavilion. So we're going to create one side of it and just mirror it and create the full geometry. So I've created 3 curves. That's all I have. They're all NURBS curves. And one thing I think is really important, just from a fundamental modeling standpoint, is you want to make sure that each curve has the same amount of control points. And so the way to make sure that is to rebuild the curves. Now the easiest way actually is to just create the first curve, copy it, manipulate it, copy it, manipulate it. That way you'll have the same curves. But for some reason, if you don't have, if you wanted to create all 3 separate curves with different control points, what you'll do is you'll select the curve and then type in rebuild, and it's going to ask for a point count. So this point count is what you will manipulate. So you can see if you add more control points, it's going to get more and more defined. And then you'll just go through and rebuild all of those curves with those amount of control points. Now, when I am usually creating my curvature, and when I'm trying to explore different geometries and different massings, I typically try and stay with a low point count, and then add as I go. Like if I get a form that I really like, but I want to add a little bit more detail or curvature in one end, I'll add control points to it. So now that those are all the same amount of points, control points, I'm going to loft them together, So once again, loft. I'm going to turn on my massing to make sure that it's meeting the dimensional requirements, which it is. And then I'm just going to take it and I'm going to mirror it down the mass. And now I have my geometry. It's kind of nice, creates some thresholds, creates a nice opening at the top. You can play with the curvature of these thresholds so they're not linear. So there's that one. All right, let's move this guy down. So this one is pretty similar to the first, or the second, excuse me. But just is looking at a more curvature, curvilinear profiles and section lines. So these, I just took pretty simple curve, basically 5 control points, and built it here. I can show you really quick. If you just take and do 3-point, select it, rebuild, turn it to 5 control points, and then you can take these two, move it down, and then take this one, and that's relatively the geometry. And then I basically just copied that down and then took that top control point, I'll turn the mask off, and just pulled it up. And so this one, you just loft it all the way down, get a nice clean symmetrical geometry. Now, if you do something relatively simple like this, I am going to expect a little bit more detail in your facade and your structure. But again, this is a pretty simple, unique. Probably want to have a little bit more. Dynamic of a. There we go. Curvature in the profile. All right, so there's that one. Now this one is a little bit funky. This one was more of a challenge for me. I saw a couple examples of it on the Google, and so I wanted to see if I could mimic it. And so ultimately this guy, real quick, ultimately this guy is just 3 or 4 curves. And I just, that one's, I think it's because I scaled it. In any case, I can rebuild this real quick. It's just a NURBS curve. That I then manipulated a bit. I'm gonna rebuild this one with, let's say, 8. I'll bring this up, bring this down, this one up as well. See, this is why I didn't want to do it with the rest of the buildings. Then I'm just going to straighten this guy out, maybe pull it out a little bit. Maybe pull this guy up a little. And then just mirrored this. I believe I just mirrored it once and then mirrored it again. Oops. Sorry. And then all I did was take some curvature and bent this guy in. And then did the same thing over here. And then did another sweep too, where I did the two ends as the rails and then the two ground curves. Oh, did I have a third one? Yep, I had a central curve, so I just selected 1, 2, 3, and then I just bent this guy down. And then rebuild it with 5. Excuse me, sorry. Rebuild it with 5. And then take these control curves, pull it up. Pull it up. So you get that kind of sloth shape. And then do another sweep 2. This, this, and then the 3 cross sections. There we go, that's more like it. Alright, so, and of course you can play with the geometries. You can add more cross section control curves if you want to have a little bit more control over the profile. But there is that one. And then the last one, the final guy, is a different technique than using cross sections or profile curvature to create the surface and lofting or sweeping. This one is actually just taking a planar surface and manipulating its control points to create the curvature. So what I'm going to do is I just have a profile there. I'm going to grab my planar surfaces, select the curve, and now it creates a plane. And then what I'm going to do is you can also use the rebuild command, on surfaces. And so you can see that it starts to build additional control points that you can edit. Right now, if I tried to points on, if you do the points on command, you only have these 4 corners, but if you do the rebuild, and then I want to switch this, so I want 6 and 3. Is that right? Sometimes it's a trial and error. What is the U and V? Yeah, I want the opposite. 3 and 6. All right, so I did 3 and 6. Now I'm going to do points on. So now I have a bunch of different control points that I can manipulate. So you can start to pull up on these. And this is the gumball down here. So if you don't see those, make sure you have those turned on. And then you can just start to pull up on the different control points, start to manipulate that surface however you want. Obviously you don't have to be constrained by the bounds. You can pull in or out however you want to create some funky, unique forms, whatever you're feeling. Just remember to verify all of this with your bounding box to make sure that you're at least hitting the height, width, and length requirements at least at some point. so you can pull it out too, or pull it in, whatever you are feeling. All right, so those are just a couple different ways to create some different double curved geometry that you can use for your pavilion. The next video will show how to import this into Grasshopper, which honestly y'all should know, but I will also then show you guys a couple new tools in Lunchbox on how to quickly panelize the surface.